to Mike Academy. So in today's video, we are going to be looking at the Newton-Raphson's method of numerical methods in engineering mathematics. And we are going to be considering this question, x equals cos x, to explain this concept. So let's say we're asked to approximate the root of this equation, x equals cos x. Now, the first thing I will ask you to do is not to send x to this side of the equation, but rather to send cos x over to this side of the equation. It makes it very easy to be solved like that. Okay, so we're going to have x minus cos x to be equal to 0. So this simply now implies that my function f of x is now equal to x minus cos x. Now let's take down our Newton-Raphson's formula. The formula simply states that xn plus 1 is equal to xn minus f of xn all over f prime of xn, and you have this. So it means now that we need to find our initial guess xn, and the initial guess usually starts from 0, s0. Now to find our initial guess, I've always said you look for two values such that when you plug them into this function, it turns the function directly from positive to negative or directly from negative into positive. And when you get those two values, then your initial guess s0 is taken simply as a plus b divided by 2, where a is the value that causes the function to be turned into positive and b is the value that causes the function to be turned into negative. So let's take a scale of 0 and 1. Okay, so 0, 1, 2, 3, and so on. So also keep it in mind, when it comes to trigonometric functions, please put your calculator in radian mode, okay, to be able to punch any three value, right? So if I want to punch, for instance, cos 0 or cos 0.5, the value, if I punch cos 0.5 when it is in radian, is different from when it is in degrees. If you keep it in degrees, your root might not converge. Okay, so the best way to get the root converging faster is by setting your calculator in radian mode to punch trigonometric functions. All right, so let's start with 0. F of 0 is going to be equal to 0 minus cos 0, and of course cos 0 is simply 1, both in radian mode or in degrees. So this will give us negative 1. Now this value is simply what? Negative. Now we try the next value when x is equal to 1. So we punch f of 1. This is going to be equal to 1 minus cos 1. Okay, so this is going to be 1 minus, let's find what cos 1 is. So remember to put your calculator in radian mode for this. Okay, so cos 1 gives us simply 0.5403, approximately 0.5403. So we have this. So this simply implies that 1 minus 0.5403, that simply gives us 0.4597. So we have 0.4597, and this value is positive. So you see that this root changes directly from negative into what? Positive when we choose x to be 0 and when we choose x to be 1. So this simply implies that a is a value that causes the function to be positive, and that value is 1, and b is the value that causes the function to be negative, and that value is 0. So we can now find our initial guess. X0 equals, so this is simply saying x0 equals 0 plus 1 divided by 2, which simply implies that our initial guess x0 is going to be equal to 0.5. Okay, so having found 0.5, the next thing to do now from the formula is we now represent everything here now to find the first root. So to get the first root, it means n has to be equal to 0. Okay, so from here xn plus 1 becomes x0 plus 1, and 0 plus 1 becomes 1. So that gives us our first root. X1 equals xn here becomes x0 minus f of x0 again, all over f prime of x0, and you have this. So we need to find the value of the function at the initial guess. We also need to find the derivative of the function and then find the value of that derivative also at the initial guess. So let's start by differentiating this function. So we know our f of x, we can simply find f prime of x. If I differentiate x, that will simply give me 1. If I differentiate cos x, I will have negative sine x. That minus multiplied by this minus becomes what? Positive. So I have plus sine x. So the derivative simply gives me 1 plus sine x. Okay. So now that I know all my parameters, let me start plugging in the initial guess into the functions. So I will find first f of 0.5, which is f of x naught, and that simply gives me 0.5 in place of x. Wherever you see x, now put in the value at 0.5. So I have 0.5 minus cos 0.5. Don't forget to put your calculator in radian mode to punch cos 0.5. So I'm going to punch everything all together just to save time. Do well to punch along to avoid calculation errors. So f of 0.5 simply gives us, let's find the value, 0.5 minus cos 0.5. That simply gives us negative 0.3776. Okay, so I have f of x naught to be negative 0.3776. Next, I find f prime of x naught, which means the derivative at that given initial guess. So remember the formula for the derivative, it is 1 plus sine x. So you have 1 plus sine x now is 0.5. So this is going to be equal to, so once again, do not forget to put your calculator in radian mode, to be able to punch sine 0.5. So you have the same value that I'm having. So 1 plus sine 0.5, I'll punch all together. That simply gives me 1.4794. So I have approximately 1.4794. Okay, having found these values now, I can now find my first root. X1 is going to be equal to, we said x naught, and x naught is 0.5 minus f of x naught. F of x naught give us negative 0.3776. So I have negative 0.3776 divided by f prime of x naught, which gave us 1.4794. So divide 1.4794. This is going to be equal to 0.5. Okay, this minus and this minus becomes positive. Now let's find this ratio. 0.3776 divides 1.4794. That gives us simply 0.2552. So this simply implies that our first root, x1, is going to be equal to 0.5 plus 0.2552. That gives us 0.7552. So we have now our first root. Having found our first root, the next thing to do is to plug the first root back into what? The equation. Okay, back into the equation. So we need to now find the second root, which is x2. So for the second root, it means n now becomes what? N now becomes 1, right? To find the first root, n was 0. So to find the second root, n becomes 1. That is how we carry out our second iteration. So in the formula now, instead of x naught here, this becomes x1, okay, minus f of x1 all over f prime of x1. So once again, this is going to be equal to, we know what x1 is, 0.7552 minus, so we need to find the function at x1, find the derivative of the function also at x1. So we'll move over here now. So we find f of x1, which means plugging the value of x1 into the function. Function is x minus cos x. X1 now is 0.7552 minus cos 0.7552. So I'll punch everything all together. Also, do not forget to put your calculator in radian mode to have the same values as we are having. So let's do this now and see. So everything gives us 0.0271 upon evaluation. Next, we'll find f prime of x1. So f prime of x1 simply means plugging the value of x1 into x in f prime. So f prime here gives us 1 plus sine x. X now becomes x1, which is 0.7552. So let's see what that gives us. That simply gives us 1.6854. So we have 1.6854. So having found this, now we can simply plug into the formula to find the second root. So we have this here plus f of x, minus f of x naught, f of x1, that gives us 0.0271. So minus 0.0271 divided by f prime of x1, will give us 1.6854. So divide 1.6854. So this means our second root is going to be equal to, so I have 0.7552 minus, let us find this ratio. Okay, so 0.0271 divided by 1.6854. That ratio simply gives us 0.0271. 0.0161. Okay, so if you evaluate this, you simply find your second root x2 to be equal to, so let's find 0.7552 minus 0.0161. So that difference simply gives us 0.7391. Also observe how we take at least up to 4 decimal places in iteration. So always when you're iterating, always remember to keep it at least up to 4 decimal places. And then you try to investigate if at least 2 converges, you can stop your iteration. But depend on how many decimal places that you are required to actually look for then. But if you're not given any specific decimal points, once at least 2 converges, you can stop your iteration. But in this video, I'm going to try to make sure the 4 of them converge. So we're going to keep on iterating until the root of the equation completely converge. So s2 here is 0.7391, and so we can now find our third root, which is x3. So to find x3, it means that x2 now replaces the formula. So in the formula, instead of x1, okay, from there, instead of x1, this becomes now x2 minus f of x2 divides f prime of x2. So we need to find the value of the function at x2 and its derivative also at x2. But then this is equal to, we know what x2 is, we just obtain the value here, 0.7391. So we have 0.7391 minus, let us find f of x2. So f of x2 is going to be equal to the value of the function in the value of x2 into the function. So we have x minus cos x. X itself is 0.7391. So we have 0.7391 minus cos 0.7391. So if you evaluate this, you're going to have, don't forget to put your calc in radian mode. So upon evaluation, this gives us approximately 0.0000, which you can simply call 0, right? So let's find f prime of x2, which is going to be equal to 1 plus sine 0.7391. So this simply gives us approximately 1.6736. All right, so having found this, you simply effect that here. So you have f of x naught, which gave us approximately 0, divides f prime of x naught, sorry, f of x2, this is f prime of x2, which is 1.6736. So this means that our third root x3 is going to now be 0.7391 minus 0 divided by this obviously is 0. So this simply implies that the root of that equation x3 is going to be equal to 0.7391. So as can be seen, this converged with the previous root. We have the same result, correct to 4 decimal place, 0.7391. So this, you can see how fast this root converged, because it boils down to the first thing I said earlier. Instead of sending x over here to have cos x minus x, simply bring cos x over here to have x minus cos x, and that actually helped this root to converge quickly. So if you had sent x over here, it will take you at least up to 5 iterations before you can be able to find the root of the equation, but the result will still remain the same, but at least you spent more work in doing that other than using this other approach. All right guys, so that's how you employ the Newton-Raphson's method of numerical methods to approximate the root of x equals cos x. In the next video, we are going to be looking at using the Newton-Raphson's method to approximate the root of log x minus 1.2. I'm sure you want to be a part of that video, so do well to turn on your notification bell and tap the subscribe button right now so you don't miss out on that video when it drops. In the meantime, do well to like this video, share to your friends, and comment nicely. I will see you in the next video. Cheers.